Okay. That looks okay, huh?
Yeah, look at mine.
More screens.
All right, folks, it's time to get ready. Let's go. I did not.
Hey, folks. This is the TLS working group meeting. If you are not here for the TLS working group meeting, then you should probably be somewhere else. We need a note taker. Do we have any note takers? It's pretty important that we get a note taker. Got notes? Thank you. And is somebody on Jabber? Do we have somebody on Jabber? Thank you. All right. So you all should be familiar with the note well. If not, you can take a few seconds here to familiarize yourself with it. Okay, and the blue sheet should be going around. Please remember when you get up to the mic to speak, please state your name. And as always, let's try to keep it professional at the mic.
Fair enough. All right. Next is the agenda. So today we got two sessions. One is an hour long. We have some things that are pretty crammed in there. Hopefully, can everybody hear me all right? All right, good. So this is the agenda, and this is the agenda bash time. Stephen.
Hi, Stephen Farrell. I'd like to bash the agenda a little. Or to understand it, I asked on the list what was the basis of having this visibility discussion again. Given that we had this discussion, there was no consensus to do anything. We had this draft. It was discussed at length on the list back in September, October last year. And here we are again. I don't understand the logic by which we're having this discussion today.
So we've gone back and looked at the messages that have been around this draft, and there are both people who are vehemently against this idea and people who think it's critical for the operation of what they do. There's also people who have different technical contributions or opinions as to how things should be done. So we felt it was still appropriate to have this discussion here in London.
So again, I mean, I won't belabor the point, but I just don't understand the logic that gets us constantly doing this. Is all that's needed is somebody to have strong opinions, and then we're going to have this discussion every year? Seems like.
I hope not.
So, I mean, I still consider that question is not answered.
Which question?
How is it in our process to be having this discussion over and over again when we have there's an obvious lack of consensus here? Why do we keep having this discussion?
Because people have brought new work to try to address some of the reasons why we did not have consensus.
But okay, again, that was discussed on the list at length, with a very clear,
I don't think that it was very clear on the list.
I thought the lack of consensus was as clear as ever.
So Kathleen Moriarty, Area Director. So I do support the chairs in this to allow the conversation to continue, because part of the consensus process is to figure out if there is a way that people can move forward without valid, strong technical opposition. So there may be a way to get towards that, and it would be good to see.
Ted Lemon, I think actually that what Kathleen just said is a great way to focus the discussion. If there are proposals that don't have strong technical objections, perhaps those would be the ones that we should consider discussing and not other proposals that do.
All right, thanks. So the first thing we're going to do is do the document status on a slightly happier note. TLS 1.3, I guess, is an approved point raised at this point. We spun a new version to deal with one little thing. We'll talk about, like, for 10 seconds about that on Wednesday. ECC cipher suites for TLS 1.2 and earlier, and the ECDH PSKey stuff is in the RFC editors queue. It's pinned on a kernel pkix draft. That is on the IETF chat, I believe, in the first week of April. So those should go. The DNSSEC draft is being clawed back to the working group based on some ISG discusses and some other things that they pointed out the last second. And we have 2 drafts that are on the telechat again for early in April. And then we have a whole bunch of drafts that are kind of in play. And we're going to be discussing most of those on Wednesday. All right. First up, it's Thomas, the record header extension. Where is he? There he is. Great.
Hi. Next, please. So, yeah. So, what's this thing? Is a way to provide a. It's a way to extend the existing header. And how did we get here? Is we get there by looking at places where we could actually signal the presence of the seed, and we're looking at various places. There's a scarcity of place where to actually encode that semantics, but there's this lonely MSB in the length, which is unused, which could be used for that, and then we observe the thing that if we are not greedy and we don't allocate that bit for the seed only, but we allow, we sacrifice one more byte, say, for explicitly typing the extension that we want to have, we can actually create a generic extension mechanism on top of that single bit. Next, please. So how does it work? The MSB is assigned this new semantics, is the extension bit. If it is asserted, then the space between the header and the payload is, we can carve space there and encode a certain number of extensions that have the format that is at the bottom of the slide, where basically a TLV with a bit, the MSB of this thing that signifies the presence of a further extension. So you can stack the extension effectively by asserting that M bit on the extensions itself. Next, please. So, okay. What are the design criteria here? So we wanted to have a very, very limited vocabulary, and in fact we have 4-bit only, so we have 16 code points. And this because we recognize the fact that this mechanism could be used potentially to, so there's privacy implications here, and so keeping this vocabulary very, very narrow allows a working group to exert the right amount of control over this code space. For now, the only envisaged use of this extension is the connection ID. But it was suggested in an offline conversation with Xing that we could do something more than just the connection ID, and have and allocate another code point to actually resolve the asymmetry that we have in 1.3 and 1.2 as with regards to the connection ID. The connection ID can only, so 1.3 endpoints can update the seed midlife, whereas 1.2 endpoints are stuck with the actual seed that was negotiated at handshake. If we had something like this, we could use a new extension to encode the semantics, right, and have feature parity between 1.2 and 1.3, which seems rather cool. The other design criteria is that this thing is only usable when both endpoints agree, right? And in order to do that, we hook this, we bind this mechanism with an extension. There must be an extension that negotiates a specific header extension, and this extension can be used, can be encoded on the wire only when the negotiation has completed. So wherever that point is in the handshake or after the handshake. Okay, so you can start using the EBIT only after the handshake has successfully completed. And this allows also backwards compatibility, right, with endpoints that don't understand the semantics. Next, please. Okay, so an example. Suppose that we have 1.2 endpoints that have not negotiated the seed. How would we use this framework in this specific case? We have the EBIT. So next, please. We assert that bit. Next. The space between the header and the payload opens up, and you read the first 2 bytes. And next, please. You identify the type, which is 00 in this case. The seed is 00 because the first one that's been allocated. And then next, please. You read the length is 2 bytes. So next, please. You consume the next 2 bytes, 41, 42, AB. Perfect. You get the seed. You extract it. Next, please. You read back the top bit, and there's no other extension. So you're done with it. And then next, please. So you start consuming the payload given the length. So the length must be. You need to subtract, of course, the length of the extension or the stack of extensions that you have there, and then you can start reading the payload. Next, please. So there's been, okay, so in 00, a couple of months ago, we proposed a generic mechanism that included TLS as well as DTLS. We had a few interesting exchanges on the mailing list, and in particular with Adam and Yoav, and we decided for the moment to switch off TLS because it seems to be it's going to be undeployed in the wild because of intercepted middle boxes, which needs to behave as servers. So if they don't understand the semantics, they will just break the connection. Or if the other option is that they cancel out the extension because they don't know what the semantic is, and so the thing can't be negotiated end to end. So for the 01 is only the only focus for 01 is DTLS. Next, please. So we think that from a design standpoint, this thing is sort of done. We don't want to spend more time on it if this is not perceived as something useful. So I think the question for the working group is it a valuable thing to have, and should we continue this? So express yourself.
Eric Scorlage is my regular hat on. So, I mean, the usual reason why you in-band signal on a packet, whether an option exists, is because there's ambiguity about the state of the packet, because it can't be interpreted independently. But in this case, because it's part of an association, you do in fact know the state of the packet because you know what the state of the association is. And so now I'm sure you're going to say you don't know if you have for tuple overloading, then you don't know which association it is. But for that, you use the CID. So I guess I don't understand. If you have a way to indicate the CID, then you can look up the packet and look at the association, and then you know the state, and then you can put any other crap you want after that because you can independently negotiate that. So I don't understand why you need a generic extension mechanism that is keyed off of a bit of the header. And I mean, to be concrete about this, like that's what we're doing in Quick. In Quick, like if anything can be inferred from the state of we just arrange that you can look up the connection, and once you can look up the connection, everything is inferred from the state of the connection, not in band indicated in the header.
There's two different design, right? So one is packets that describes themselves as they are, so
right.
Self-describing thing, and things that don't describe themselves and rely on state that there's. I think it's taste.
But I mean, it's waste. I mean, DTLS is an association-oriented protocol, right? So things shouldn't be in the packet headers unless they have to be in the packet headers to interpret the packet. Okay, well, I mean, you asked what people thought.
Yeah, I think it's philosophy here, but anyway.
Daniel Kahn-Gilmore, ACLU. We already had this whole SPUD presentation a little while ago, and this smells a lot to me like SPUD just moved one layer down.
No.
Well-
SPUD allowed signal from endpoint to path, path to endpoint, anything. This is not SPUD.
Well, what
This is
SPUD-
endpoint to endpoint. After negotiation, SPUD is completely different.
There's a similarity. I agree it's different. The similarity is that it's an arbitrarily extensible metadata field outside the encrypted envelope.
We recognize this, and the design criteria about containing the space that code points, the code point space is exactly in this direction.
So we can tell people not
to
to use
tighten the
it.
thing.
We can tell people not to use the space, or we can not design the space, and then people can't use it. So it seems to me like if your goal is a privacy-oriented thing, where you say we have this one goal, which is the connection ID, you don't make the generically extensible thing. You say we're going to use this one bit to signal the presence of connection ID, and I understand why that's nervous, why that makes people nervous. But I'm just saying we had the SPUD discussion. We didn't do SPUD. I'd rather that we don't do something SPUD-like at the next layer up.
Okay, I don't agree with this analogy, but anyway.
All right, Martin, you're at the end of the line.
Yeah, evidently. Martin Thompson. I think I agree mostly with Eka here. There are sort of a number of cases that you're concerned about, but the only thing this actually helps with is in the case where you have packets that arrive from on a different four-tuple than the one that the connection was established on, and you don't have any expectation about whether those packets came from a connection that had connection ID or one that didn't. And I think that's vanishingly rare. Those cases that actually have this problem, the clients and servers that care about it will be deploying the connection ID, and you'll have a connection ID on those packets that arrive. And those that don't, well, too bad. If you look at this and you assume that packets that arrive on a four-tuple, five-tuple, whatever you want to call the damn thing, is that you don't have an association for. They come in, you don't know which connection it belongs to. You assume that it has a connection ID and you proceed based on that. You'll very quickly realize that it just continues to work at that point.
I'd like to avoid this trial and error thing, right?
Well,
And
unfortunately,
simplify-
you're running DTLS and packets. It turns out that packets come from everywhere on the internet, and there's a lot of trash. And so you're going to have to deal with that anyways. Just treat them like trash at that point.
I don't want to waste cycles I want to avoid wasting too much cycles to treat those trash, if possible.
Okay. So in what environment do you not have to deal with trash?
IoT for the moment? I don't know.
Honest.
Martin, are you essentially saying, so sort of Thomas is proposing to have a mechanism to indicate in the lens field, but take one bit on the lens field to then indicate whether the CID is there or not. And then of course there's all you went a little bit further to generalize this, but you are essentially saying that you want to use a probabilistic scheme in some sense. No.
Not quite that bad. So my assertion is that any client that is that does not implement connection IDs has some sort of expectation already that they have stable five tuples. Yeah. And in the event of a NAT rebinding or some of these events that we actually care about that might cause us to want to do connection ID, then you'll get a few packets. Those packets will drop on the floor, and then the story will be over.
Okay. I think actually that topic is on schedule for Wednesday. My understanding is we're talking about connection ID on Wednesday, and this is just about this extension proposal.
So, yeah, I'd like to separate the two discussions. I did the example of connection ID, but this is an example to instantiate a generic mechanism, and I'd like to collect information and so if you like this thing or you don't like, if you think it's useful, if you don't think, because otherwise I'm not wasting time. Right.
I apologize.
Okay. I think we need to move on to the next topic. Can be quick.
Super quick. So, as Eka said, connection ID should be Wednesday. In context of connection ID, I think I like the overall idea. I don't think you need the generalized part because you have no other application at this point.
Okay. All right, Richard. Is this the second slide? Sorry.
Yeah, so I'd like to thank the chairs for letting me be the opening act for the big show. This is a late submission. We didn't get this draft put together until after the deadline, so I only get 2 minutes. This is mainly the question of, does anyone else find this an interesting problem? So Owen Friel and I came across a use case where we wanted to use TLS with a short, low entropy password for authentication. If we were looking at 1.2, we could have used SRP, but that turns out not to map really well to 1.3. So we're starting to look at, could we use an extension to map any PAKE really, but we went with SPAKE2 for the moment for the key exchange and authentication in TLS 1.3. So next slide, please. If you look at the draft, this is kind of what we've sketched out. You stick an extension in the client hello server hello that does the key exchange, much like the key share extension, and then you use the finished messages, the finished max, to do the key confirmation with the intermediate results, the password and the derived keys plugged into the key schedule, the appropriate parts. So I think I don't have time for questions, but please feel free to see me on the break or follow up on email. I would love to find out if there's folks interested in doing PAKEs for TLS 1.3. Thanks.
All right, Russ, you're up. What's that? Hmm? Wow.
Do you want to do that first?
Maybe you do it first if you want.
Which one? Do you want to do these first?
So, I mean, the premise of this discussion really is to figure out if we're going to end up at a point where we can make a hum for adoption for this draft, essentially. The draft doesn't have to be perfect when it gets adopted by the working group, because the working group gets change control of the document, and we can change it if we were to adopt it. So I want people to remember that. There's not an idea that it has to be perfectly polished before we move on. So I think that's pretty much what I wanted to say. And we're going to have Russ give a quick discussion about the technical points of the draft, and then we're actually going to go ahead and have like a 10-minute discussion, and then we've reserved 10 minutes to kind of go through the hums. And I'm sure that you will agenda bash and want to put editorial input on it. So basically the idea is going to be a straight up down yes or no. Because we feel that we've kind of discussed this at length about the rationale for why you would do it and why you wouldn't, and why people agreed and didn't. And we think we've kind of, we're past that point. We're at the point where we have a technical solution that we would like to adopt that is arguably, some will make that argument that it's in scope of the working group because it's a TLS extension. And to be honest, if they want to proceed and do anything, the first thing that they have to do is come to us and ask us. So that's what they're actually doing, and that's the plan for today. Russ.
Okay, Russ Housley. I'm presenting a draft that Ralph Drowns and I've worked on together. So the need for this has been discussed at length, and I'm not going to go through that again, but I do think that you should take a look at these two drafts if you're new to this discussion, so you know why we have it. At the end of that discussion in Seoul, we heard that people were much happier with an opt-in approach. That is where the client had to do something to say, I'm okay with this visibility happening, as opposed to the previous approach, which only the server had to interact with the key manager and the client was completely unaware. So what we have done is put together an approach that does that. Stephen, I'd like to go through all the slides and do questions. Is that okay?
It's just a clarifying question.
Okay.
So, can you explain what the word many means to you compared to the people who asked for this and the people who have had other objections?
I think many indicated that they were more comfortable. You're asking what many meant?
Right. I think I remember like one or two people made that comment, and many, in my definition, many people had other comments.
Okay, I can't say I added them up. I do recall that Nick Sullivan posted a message that kind of summarized an approach that he was more comfortable with, and we've talked about that on the mail list in the past week. No consensus call was made on that point. That's certainly true. So the goals of this extension is to address the impact that going to ECDH will have in the data center environment. The extension provides an opt-in mechanism that allows a TLS client and a server to negotiate and agree whether this visibility will be granted. The enterprise key manager is the one who decides who the other parties are that can see it. Any third party can detect whether this is going on by seeing the extension being in plain text in the client hello or the server hello. And no private keys are disclosed here, so no party can masquerade in a new session as either of the parties. Next slide, please. So the prerequisite before the extension is used involves the key manager distributing these values to the parties that will be granted access to the ciphertext. They generate this Diffie-Hellman value and pass it along to the server, gets the public and the parties that are going to be granted access to the ciphertext, get the private, and then an AED is used to wrap up the things that they need to get to the ultimate key. We didn't want to make up a way to name these things, so we just used a fingerprint, which is the SHA-256 hash of the public key to name that wrapping key pair. Next slide. So the idea is that the client includes an extension that has an empty structure that says, I'm willing to participate in this. The server then uses the public key that the public key that it has and the private key that the other parties have to wrap up the information that is needed for the decrypt to happen, and passes that along. So any of the parties who are going to be doing the decryption decrypt the information in the server hello in order to get to the things that allow it to compute the key schedule to decrypt the rest. Earlier this week, we heard about a different approach that didn't include the resumption key. If the group adopts this, we will be glad to work through those details and do whichever the consensus of the group is. Next slide. So this is the syntax actually of the stuff that goes into the extensions. I don't want to walk through the details other than the fingerprint is there to know whether you have the key pair that you need to get to it. And then the ephemeral public key that is generated by the server for this particular wrapping. And then the wrapped up secrets that are recovered by the other parties based on the private key that was passed out by the key manager. Next slide. These are the details of how that encryption happens. I think the text at the bottom shows that we're just using the HKDF extract and expand mechanisms to get to those keys, very much similar to the way the key schedule is used. Again, subject to all these details, be glad to talk about if the group even wants to go forward with this draft. Next slide. Questions, and I think we want to start with the questions of understanding the draft. And if there are none of those, then we'll turn it over to the chairs for the discussion in the homes. Yes.
Stephen Farrell. So if I understand this draft correctly, you're just omitting the snoopers bits, and there's no concept of whether there's 1 or 0 or more than, well, zero is a concept, but you don't have a concept of having more than one of those, as far as I understand it.
More than one of those
Snoopers.
Other parties that can get to the ciphertext.
Right.
Right. So the key manager decides who those are. And the client doesn't know who they are.
Sure, but you don't have a concept where in a single session you can export the stuff to more than one snooper independently, right?
More than one snooper is, I didn't get that word.
Yeah,
that's correct.
Right. So, and does that, given the draft Fenter that you mentioned, does that match their use cases at all? Because they mentioned multiple different, many different reasons why they want to snoop on the data all over the place, right?
Yes.
So you think it's all the same team that's doing that?
No, because each session the server's picking a different ephemeral, so that's not the case. Ben.
Ben Kaduk. So if I understand correctly, the use case here is in the data center and it's server to server. So my question is, does there need to be a negotiation in the protocol sense, or is this something that could just be pre-agreed that you are going to do something of this nature?
Sure, that's a possibility. The people who raised concerns and wanted the opt-in did not like draft green because draft green did exactly what you just said. It was totally between the server and the key manager, and the key manager deciding who they could be. So based on those concerns, we took this approach.
I'm talking about negotiating between the TLS client and the TLS server with no necessary consideration to the key manager.
Well, then I don't understand your question. Sorry.
So in TLS, we have these extensions that are frequently used to negotiate the use of certain protocol features.
Correct.
In the data center, you frequently know that you're going to be talking to a specific peer that has a specific implementation and specific features. So in principle, you could bilaterally decide that between a given set of peers, you're going to do some particular thing, which may look a lot like TLS and may not be exactly TLS. And I'm trying to understand if you need this in-protocol negotiation, or if you could do some out-of-band agreement that some sort of visibility or whatever you want to call it mechanism will be in use.
So what I heard you saying is, can't you create a TS-like protocol for use in the data center that allows this visibility? And that would be another design choice, not the one we're presenting. Darren.
Thank you, Russ. Darren Pettis, US Bank. I just wanted to speak to Stephen's question of why do we keep talking about this. I think the fact that people continue to come here and share the reasons of why this needs to be addressed for data center decryption speaks to the continued need. I mean, we all go to the doctor, we all go to retail stores. This is going to affect all of us individually. So I think a lot of good things have been done on the internet. I'm not against end-to-end. I'm a privacy advocate myself. But I also understand that we have to look at the data once it's sent to us, because it's destined to us. It's not transitory anymore. It's destined to us, and we're responsible for securing it and ensuring the performance. So, just like to say that we'd like to ask for a vote forward for this. We'll rip the Band-Aid off and go ahead and take this work into account, please. Thank you.
Philip?
Phil Humbaker, Komodo Group. I agree that this is a very important use case, and in particular in the SCADA world. When I was working on a chemical plant, there's no way that we could have a communication going on that we couldn't strap an analyzer on to look at what that traffic was. So visibility of the traffic was more important to us than confidentiality. Our big concern was always integrity. That said, I think that I think that this proposal that is made doesn't quite have the sufficient degree of control. So I've developed my own proposal and applied for a patent on it. Because there are two ways to adopt a standard. One is to go through a process like this, and another is to be told what to do by an IPR holder who can get everybody to do it the same way.
Hi, you have near not channeling anyone, and I don't have a proposal myself. The thing we talked about in Prague was about offline decryption after the fact. And what this draft proposes is decryption online. So, which is it? Because what we need for network operations is the offline thing, what we talked about in Prague. If we're going to decrypt online, for example, for anti-malware, then we have to have it online, and then we really have to change the protocol because there's no other way to get the keys into the middle box on time. On the other hand, I could make the case that anti-malware doesn't work like that, because anti-malware shouldn't be in the TLS layer. It should be much higher up the stack, because anti-malware works in resources. So you might want to, if you want to analyze one of the resources, you want to block at that point, at the middle box, not forward the resource at all to the client or the server, whichever way the connection goes, and run all the malware on the full resource that at that point is only on the middle box, but not yet on the client, without breaking the connection. So I don't think anti-malware can work with passive inspection of TLS. It can only work with an actual proxy. So I'm not really sure why we need this proposal that alters the protocol only to get us passive decryption, where I don't think it's really needed.
So we've looked at this, and there's use cases where you need to deal with it real time immediately, and there's also use cases where the traffic is stored and then looked at later. So we tried to come up with one that accommodated both, as opposed to coming up with two solutions for each of those environments.
Well, yeah, but since some of the use cases do need the proxy anyway, and proxies work with TLS 1.3 just as well as they work with TLS 1.2. Why don't we just tell people, okay, use a TLS proxy, because that's the only thing that will cover all the use cases.
No, I said proxies were used in some cases, but not all.
I think they solve everything. They're just heavier-handed.
The heavier-handed, yes.
Hi, Nick Sullivan. There's just one thing I want to clarify with this draft is the visibility endpoint, does it have the ability to compute exporters based on?
So the way I wrote it, yes. And then on the list last week, I said, you know, another way to do this would be to pick the 6 values, I believe, that were necessary to decrypt the zero RTT data, the handshake data, and the payloads without giving access to compute the PSKs for subsequent resumption or the exporters. And if the group wants to do this, we can have the trade-off discussion and pick whichever.
Thank you.
Mm-hmm.
Paul Barrett, NetScout. A couple of comments. Like everyone, I'm a big +1 for privacy on the open internet. I think you also have to acknowledge a lot of the value of the internet comes from the content provided by data centers. I know that the vast majority of large data center operators do use packet flow analysis for network assurance, application assurance, cybersecurity analysis. Doesn't matter if they're a for-profit, not-profit. I know from my own dealings that a minimum of 85% of the Fortune 500 do this. As for the draft, you know, the way I look at it is, and I followed this quite closely, that the authors have listened carefully to the concerns that were raised by Draft Green. I believe that they've addressed those. They've found a technical solution that, in my mind, meets the requirements of both privacy on the open internet and the requirements of data center operators.
Steve Fenter. I wanted to make a comment about the use cases of after-the-fact versus live out-of-band decryption. Certainly, after-the-fact decryption is useful for troubleshooting, but there are a number of live out-of-band use cases for decryption. Application performance monitoring with packets, for example, may look at many tiers of an application, and the packets need to be decrypted immediately. Metadata is created, and the packets are thrown away. Of course, IDS, customer experience monitoring, fraud monitoring is another live application that's done in multiple locations. And a last example I'll mention, since I'm a troubleshooter, for very large, complicated applications with many tiers, it just takes too long to take one sniffer and try to chase around the problem, waiting for multiple occurrences. So what you have to do sometimes to be effective is to put traces at many layers of an application at once. You run them through a packet broker, through a decryption appliance, and into a sniffer, so that when a problem hits, all the data you need is there.
So do we have questions about the draft is what we really want to get to, and then we can go on.
Sure.
Thanks. Stephen, is there anybody else in line that wants to comment directly on this draft? Okay, so Stephen, do you want to go first, since I think you were in line first before the other gentleman?
Sure. Stephen Farrell. So Russ, how would you characterize the difference in analysis between the work to develop TLS 1.3 and the work on this draft?
How would I characterize the difference between TLS 1.3 without this extension and with this extension?
No. How would you characterize the level of analysis that's been done to produce TLS 1.3 versus this draft?
So, TLS 1.3 has gone through a huge amount of analysis. This one is a proposal that is not yet. I would say we're at the same stage we were when TLS was at 0.1 or 0.2.
And this is maybe getting towards commentary, but would you not agree that we have learned over the last 20 years that doing the kind of analysis that we did for TLS 1.3 is now what's the right thing to do, and not
absolutely
the back of an envelope kind of thing which this appears to me to be?
No, I think we would need to do that same level of analysis if the working group wants to go forward with this extension.
Which then confuses me with the, if that level of analysis might say that this extension is just a terribly bad idea. Shouldn't you have done that first?
No, I don't think you need that first, in the same way we didn't do it with 0.00102 of TLS. We did it as we worked on it.
I don't find that very convincing at all.
Ted, do you have a technical comment about the draft?
I got up to make a comment about the point Steve Barrett made, but it is more a point about the non-technical comment, if you'd like me to wait.
Yeah, because I think there was somebody that had a technical comment. The gentleman behind Nalini.
I had a clarifying question, if that's okay.
Sure.
Because in the David Skenazy, Apple. In the conversation here, I've heard the words data center and enterprise thrown around a lot. Can you clarify what client and what server is being used? Are those general purpose hosts or data center servers?
So very often it will be the load balancer at the edge of the data center that will be the client. But we, after talking to a bunch of different financial institutions, found that there were some cases where the client was outside the data center, and therefore it could even be a browser or a point of sale terminal or something like that.
Thank you, because if it's purely data center, then as some people suggested, you don't necessarily need to be using TLS. And if it's another browser clients, and hypothetically speaking, if the people who implement those browsers have expressed discontent, hypothetically, and do not wish to implement this, what's the point?
Indeed.
Ted Hardy, it turns out that my point was actually a follow-on both to Steve and to the point that was just made, because I think Steve's point was that there were data center workloads where this was valuable inside a data center. And I work for Google, and our experience is sometimes our expectation of what's private to a data center is frustrated by outside observers who have very nasty sticky notes to put on slides that Edward Snowden eventually lets us see. And the upshot of that is that I think when we examine this and do the analysis, we have to presume that for the purposes of the analysis, it will take place on the open internet. And I believe that that also means that we have to understand that it would get used in places where the number of distribution points which receive the keying information will not be one. There are a fair number of state actors who might require that particular operators share such information within their territories, and that if they were provided this facility, that keying material might go to them for later analysis. And I think that as part of the analysis of this header, if it's accepted and you go through what the process that you and Stephen just agreed would occur if it did, that has to be taken account in the analysis. And I think that
that's a fair point.
The only thing I can see personally that would stop that is making part of this protocol a sharing of the identities of all the listeners at the time of the negotiation of this header. That makes it much, much more complicated, obviously.
Yes.
And I think that there's a real question of whether you can balance the complexity of producing a multi-party keying protocol with those characteristics against the privacy things when you don't know all of the considerations relevant to the deployment which will occur. I believe there are some use cases which have been described in which those would be relatively well understood because of the current auditing functions or other debug functions which are in place, but that once present, this would be used in places similar to the way we understand state actors and others use it now. And I think that was one of the reasons for developing TLS 1.3 the way it was developed, and that changing it is quite a serious undertaking indeed.
Okay, we got about 4 minutes, and then we want to reserve the rest of the time for the actual questions of adoption. So,
hi there, Daniel Kahn-Gilmore. Thank you for acknowledging that the goal of this is not strictly within the data center. I think that will probably change some people's analysis of it. I have a technical question, which is, from what I can tell from the way that the draft is designed, the client opts into the server sharing data with someone.
That's correct.
Anyone.
What the key manager, the guy who doles out those private
Does the client on the public internet, does the client know or have any way of verifying who the key is being shared with?
Not in the current, and that's exactly what Ted was pointing to.
Yeah, well.
It's exactly what Ted was pointing to.
Is this a design decision that you made?
It was a design decision here, which you can revisit.
So Kathleen Moriarty, Area Director, to ask some clarifying questions, because I'm still hearing some pretty major concerns that could be enough to block from a consensus standpoint, right? And what I'd like to see is, I do think the use case is important. Is there a way, and I have some thoughts and I'll throw them out, but is there a way this could be constrained to the data center usage? Now, in terms of the identities, I don't know that an end user would be able to decipher them, so I'm not sure that's a practical solution. I think we might find holes with that if you're presented with a list of who's monitoring. So I'm not sure that that would be an adequate solution. But what if this was server to server within the data center, and in the client case, they're terminating at a load balancer or some other function on the edge of the network, and then able to do server to server within the network. And then if there is a user within that enterprise that's connecting, there's another load balancer. Is this a way that it could be constrained that we could get beyond the point we're at in this argument?
I don't think that is a fruitful way forward, because my perspective from talking to people over the last almost year is that their use cases in different enterprises are diverse enough that that's not the case. You can't always say there will be a load balancer.
Okay.
Which is exactly Yo's argument, by the way, saying proxies solve this.
All right, so I'm closing the line.
Same thing. So it's something that's terminating the session to the outside.
One question, Brian Witten. It sounded like, though, you are open to the approach where the client authenticates the key manager, so the client could at least have some confident information about who the key manager is and who's facing subpoena risks and things like that. It sounded like you were at least open to exploring that.
I'd be willing to talk about that. But, you can't put forward a solution that is whole without, I don't yet know what those requirements would look like.
So the related question is, it seems to me that a fair policy logic would be for clients on the open internet that by default not accept this visibility. And a related thing would be maybe for employers when connecting to their own domain, in that exceptional case, allow domain visibility. And that still leaves the question of compulsion. Could people be compelled? But related to compulsion, those are risks that we run today with or without a standard. Do I understand all of that correctly?
That's correct.
Okay, thank you so much.
Mm-hmm.
All right, guys, I think, I guess at this point, we're trying to figure out if we can actually put the questions on the slides and if we can actually agree to the questions, because I know that people like to edit them. I've already been told that I missed a word in the second question. So the proposals that we've basically come to the conclusion is that you can wrap up all of your good thinking or bad thinking for one or the other, and this is essentially a straight up down, do you want to adopt this or not? So, the first question that we would have would be, do you support adoption? And the second one would be not. So I'm not doing it right now yet, but when we do that, we're going to get Kathleen to jump up. No, you didn't.
Okay.
Yeah.
Yep. Nalini Elkins. One of the things I'd like to say, one of the things I've seen in this whole area is there may be a way in which the IETF process does not
Nalini,
work.
we're going to have to, I think that's a larger question. I think you'll have to take up with elsewhere. I think this is not really about it's about trying to figure out whether we're going to adopt this draft, I think.
Sure. Okay.
Ben Schwartz, I just want to say it sounds like one of the purposes here is to guard against data exfiltration attacks or attacks against confidentiality within the network. I think that's one of the purposes given for this protocol, and I just want to suggest that it's not actually technically fit for purpose, that it actually increases the risk of data exfiltration attacks, because an attacker who manages to break in is now has a single point of failure within the system that would allow them to exfiltrate all plain text within the network, whereas with TLS 1.3, they would be much less likely to be able to harvest that much information for exfiltration.
Okay.
Ben Kaduk, and I think Brian sort of touched on this tangentially. I just wanted to confirm that everyone has a similar understanding with respect to the compulsion question, namely with the client offering this extension and the server having to echo it back. There is the potential for a entity that controls the network path between the client and the server to deny connections that do not contain this extension as a way of compelling the use of this extension. And if anyone disagrees with that as sort of the technical reality of the proposal, please flail around now.
All right, next.
Hey, Sharif Mansour. I share my colleague's concern with this draft that it might increase the attack surface area, while other approaches such as active proxying might provide the same kind of use case, bearing in mind that it is more expensive. So my question is just how much more costly is it, given the fact that it can provide similar use cases for it? The opt-in is by installing a cert on the browser or on the agent. Thank you.
All right, we're closing the line. Thanks. Sorry, Pete. We gotta move on here, guys. We're running out of time. Thanks. Yeah, go ahead.
Charles Thompson with Viavi Solutions. Just want to echo what Paul said earlier. Out-of-band decryption is highly prevalent in the enterprise organizations, right? 4 out of 5, in my experience, leverage some type of out-of-band. To the comments that were made earlier regarding this being data center only and perhaps the use of this on the open internet, certainly endpoints are important to be able to perform decryption at. Think about SIP endpoints, right? To be able to understand the call control when you're troubleshooting. POS endpoints in retail organizations, healthcare endpoints, right? Those are very applicable use cases where data center only applications are not applicable, and in-band is borderline non-feasible.
I assume you wanted to go last, Stephen.
No.
Okay. Do you want to go?
Sure.
Go next, Stephen?
Stephen Farrell. Can you explain to me how you think breaking TLS like this is within the scope of the working group charter?
I mean,
is that a no? You can't explain that to me?
It's a TLS extension, Stephen. I mean, like, I
don't believe this working group was chartered to include this kind of functionality. So I think that I'm speaking to your supposed questions here.
Right.
They seem to be asking can we adopt something that basically is outside the working group charter? Shouldn't you start by rechartering if you want to have a discussion?
Well, we would have to have the discussion.
We'd have to have the discussion first. I mean,
it's not like we haven't been discussing.
I know.
Okay, so I'll take it. Your answer is that no, you cannot explain to me how this is in scope of the working group.
We think it is. That's why we're doing it. Sure.
Kathleen Moriarty. So for the end user, if there were a capability on the browser side or the endpoint to be able to capture the session logs so that a user is knowingly providing that information to the party who's doing debugging, would that meet that need? No? Okay. I just wanted to ask the question to make sure that there weren't other mechanisms that might be more agreeable to the oppositions that we're hearing.
All right, don't sit down, Kathleen. So we're going to do two hums. The first one is to support adoption, and one is to oppose. So the second one, it's like, do you support adoption of draft RHRD TLS 1.3 visibility as a TLS working group item? And the next one is, do you oppose adoption? Okay. Please hum now if you support adoption of the draft RHRD TLS 1.3 visibility 01 as a TLS working group item. Thanks. Please hum now if you oppose adoption of draft RHRD TLS 1.3 visibility 01. I mean, so at this point, there is no consensus to adopt this. And so what we are basically telling the authors that if they would like to proceed forward, they need to talk to the area directors.
Area director for like 10 more minutes. Wednesday, then it's up to Ben. So I think there are very serious technical objections and they haven't been addressed yet. However, I do think the use case is very important. So from this, I don't think the draft as is a way forward, but if you look at the consensus process, if the objections were able to be met and there's some other way to do this, then perhaps there is a way forward. I don't see it with this draft at the moment, just because there are strong, serious technical objections and they haven't been met, and that's enough to break the consensus. But I do see the value in this personally. I don't know how you would detect some of the threats with the like the US CERT report that was just announced for the utility industry. And so unless there's other mechanisms in place to do that type of detection, something is needed. Maybe it's not this, but I do think something is needed right now. Otherwise, we might not have power in the US.
I think we're done, Stephen, unless you want to.
It's just a quick question for you.
Yes.
Am I interpreting you correctly to say that, so this draft is not going to be adopted? That's good. What about the next one? What's your plan there?
You mean there'll be a next one?
So at this point, they're going to have to go to the area director at this point, right? Because we are in this interesting deadlock position. So at this point, they need to go to the ADs to figure out the way forward, whether that's a new working group, whether they come back and say, no, we have to figure this out, and do come back, but they're going to get directed.
Great. So I like that answer. Thank you.
Can I squeeze one more in?
Sure.
Mike Ackerman. My question is a matter of logistics, so we're going to go to the area directors. Most of the issues that have been identified, I think, are technical. Are the area directors sufficient to address those issues, or should we start to assimilate a task force? I don't think we're going away. This is too important to all of us.
That is something you should take up with the area director.
Fair enough.
They're very technically astute, trust me.
Thank you.
Thanks. We'll see you all on Wednesday, hopefully.
Bring up the blue sheets.